Hi, my name is Jonathan Bailey and I'm in Dr. Elger's Mechanical Engineering Design class. For my LED project, I've designed the basis of a cheap and simple home security system that aims to combat real-world problems related to home security in a way that most products on the market have yet to do. Home security is an ever-present issue, not only in the United States, but all over the world. There is an abundance of security systems and devices on the market that will adequately secure a home, but many of these are expensive, often with recurring fees, and not everyone can afford the cost. The product that I've designed is a small home security system that alerts the user when a door or window has been opened. The wire is connected to a mount that can be attached to a door or a window. The door or window acts as a switch that will trigger a red LED to blink rapidly when the door or window is open, thus alerting the user that their home has been breached. The red LED will continue to blink rapidly until the device is either reset or turned off. The main idea of this prototype was to demonstrate the basics behind a potential product. The plan for an actual product would involve multiple switches connected to different red LEDs. That way, multiple doors and windows could be secured at the same time with the same system, meaning this single device could potentially secure an entire house. This mini security system has a potential for a great amount of appeal to the 5 core human drives. The system keeps homes more secure, thus protecting belongings and promoting the drive to acquire. It also means the home will be safer, providing a more conducive atmosphere for the drive to bond, as well as a home that is better protected, which correlates to the drive to defend, hence the term home defense system. As for the drive to experience, the user would probably feel more relaxed and safe knowing that their home, their possessions, and anyone else living under the same roof would be more secure. The only core drive that device may not influence would be the drive to learn, since there is little potential for educational value in this product. The potential product has a great number of benefits. The simple design means the product could be produced on very few resources. With multiple components being identical, the product could cost even less. Retailers could afford to sell the product for a very low cost, and people would probably buy it considering the product satisfies 4 or 5 core human drives. While browsing online, I found that the majority of home security products on the market tend to cost several $100s. Some of these have recurring monthly fees as well. In some cases, these products need to be installed by technicians, incurring even more fees just to get the system in place. These examples are just a few of the options available on HomeSecurityStore.com. My design has the potential to be very cheap, with no recurring fees and an easy installation. Most of the products were much more expensive, but there were a few products with some similarities. The products with the most likeness in my own was the GE51107 from Amazon.com, shown here, which costs around $30 and features a single door alarm and 3 window alarms. One of the unique things about my product is that it is very simple. The list of materials used consists of a 9-volt battery, 2 LEDs, 2 560 ohm resistors, and some wire. To add more door switches, as I mentioned earlier, one would only need more LEDs, resistors, and wiring, which are all inexpensive and easy to obtain. This flowchart represents the algorithm that runs the system. When the system is started, a red LED will light up until the pins are properly set and the door switch is closed, after which the red LED will shut off and a green LED will turn on, allowing the system to be armed. The system will then continuously check the door switch. If the switch is open, meaning the door or window is open, the red LED will flash rapidly and continue indefinitely. The schematic shown here shows the electrical systems behind the product. This one represents the setup for the product with a single door alarm. Pins 2 and 3 are outputs, supplying current for the green and red LEDs when prompted by the programming. Pin 4 is an input that will register different values for when the switch is on or off. The 2 resistors in the circuit will prevent the LEDs from drawing too much current and burning out. The most difficult part of this project was learning how to wire and program an input pin. The objective from the lab was to have LEDs light up. We learned most of what we needed about outputs in the lab, but we had not covered anything related to inputs. The greatest concern for wiring was ensuring that the Arduino itself would not be damaged by a short circuit or a current draw that was too large to handle. On the subject of programming, the most important part was keeping the format and syntax correct. I had to make several revisions just to enable the program to run for the first time. My biggest issue was probably my lack of iteration in the programming process. I didn't bother to test the program after each step. Instead, I wrote most of the program all at once and refined it until it ran properly. I was fortunate to have as few complications as I did. Before I started programming, however, I started with some physical prototypes. The majority of the process was completed during our initial lab. I started with getting a single LED to light up, and then moved on to having multiple LEDs in the circuit. When I was comfortable with that, I experimented with buttons, which gave me a bit of insight on how to proceed with a switch for the final design. I ended up finishing the programming before I was done with the wiring. At that point, I hadn't learned how to wire an input pin, so I made a second version of the program that went through the process of lighting their respective LEDs without an input. When I found that it worked, I looked at an example in the Arduino Experimenter's Guide that used an input pin and wired it so that it was similar to the schematic in the book. My initial intention for the final design was to have a piezo element that would emit a sound when a door switch was opened. As I mentioned earlier, the design was also intended to have multiple door switches. Instead, I wired up only a single switch with no sound element so that I would have a simple proof of concept design that worked 100% of the time, rather than take any unnecessary risks. Ultimately, the final design was a prototype that could be modified for greater functionality. Although I could have done a better job, I believe I did a few things right with this project. For example, I made a math model before I started wiring during the initial lab. I found that it would take a 450 ohm resistor to bring the current to a suitable level for each LED. I also improved my understanding of circuits by trying some of the examples in the experimenter's guide and using it as a reference when I needed to program an input. The most important change I need to make for my next project is to improve communication. Due to a lot of confusion and lack of proper initiative on my end, I ended up working on this design solo when I should have been working with a partner. This caused concern from both my group and myself that could have been avoided. Aside from that, I could have taken more steps to ensure my programming would run properly, such as testing it with the Arduino after each significant change. As a whole, this project was a worthwhile experience. Both the triumphs and the mistakes were valuable in learning more about becoming a well-rounded engineer. This experience gave greater insight into the importance of technical knowledge and practical skills, especially communication. The concept for the security system is also something that may have potential on the market. I am convinced that